Friends, today we are going to discuss with the second method of finding the solutions of simultaneous equations in three variables or in two variables both. So it is one of the method of finding the solution of simultaneous equations by using matrix method, and this is the second method of finding the solution by using matrix method. Okay, and that method is known as the reduction method. So what we do in this type of method, we will see with one example. So let's see one example. The example given is, the question will be like this: express the following equations in matrix form and hence solve them by using method of reduction. So it's one of the easiest method of finding the solution of simultaneous equations. You may given two equations in two variable or three equations in three variables. Okay, so let's see the equations given. They are x plus 2y plus z equal to 8, 2x plus 3y minus z equal to 11, and 3x minus y minus 2z equal to 5. Okay, so first we need to write the equations in matrix equation form. So the matrix equation is given by Ax equal to b, as we have seen in the previous method also. Okay, the first method already we have seen in the last video, that is by inversion method, right? Matrix inversion method. So this is the second method. So in matrix inversion method also we need to write the given equations in matrix form, that is known as the matrix equation. So it is given by Ax equal to b. There again A will be the matrix of coefficients of variables, x will be the matrix of the variables, and b will be the matrix of constant column matrix. X and b will always be the column matrices. Okay, so let's write it in Ax equal to b form. So your A will be the matrix given by 1 2 1 2 3 minus 1 3 minus 1 2, which is obtained from the coefficients of x y z in the three equations given. See, if you see here, the coefficient of x y z in the first equation are 1 2 1. So I have written the first row as 1 2 1. Then second row will be obtained from the second equation. The coefficients of x y z in the second equation are 2 3 and minus 1. So it is 2 3 minus 1. And in the third equation we have 3 minus 1 minus 2. So that will be the third row of this matrix. Okay, 3 minus 1 minus 2. It is multiplied by a matrix X and is equal to matrix B. Okay, so in this method of finding the solution, what we need to do, here we are going to reduce the matrix X to an upper triangular matrix. In case of the first method, what we do there, we are reducing, or we find the inverse of a matrix and then multiply that inverse of matrix to the matrix B, and then that gives us the values of x y z, that the matrix X. But in this case what we are going to do, we are going to reduce the given matrix A, that is the matrix obtained from the given equations A, that we need to reduce to an upper triangular matrix. What do you mean by upper triangular matrix? Upper triangular matrix means we need to reduce the elements of this matrix A, elements which are below the diagonal. So here is the diagonal of a matrix. So elements below the diagonal means these three elements we are going to reduce to 0, and that can be done by using the elementary transformations. Okay, that is, here we are using elementary row transformation method to reduce these three elements to 0. Okay, as we have seen in case of inverse, to find the inverse of a matrix by using row transformation, we reduce the same way we are going to reduce these three elements to 0. In case of inverse, we are supposed to reduce all the elements except the diagonal element to 0. Hence we need to reduce the matrix A to an identity matrix I. But here only the elements below the diagonal should be reduced to 0, not all non-diagonal elements to 0. Okay, instead that we need to reduce only the three elements to 0 by using the particular row transformations. Okay, so how to reduce them in to 0? Let's see here. So to reduce the matrix A to an upper triangular matrix by using elementary row transformation method. So what will be the first transformation? If we see the matrix A given here, the diagonal element in the first column, here we need to reduce the first column to 1 0 0, as we do in the inverse of a matrix. In the row transformation method, we have to reduce this first column to 1 0 0. So already the diagonal element is already 1, so no need to reduce it to 1. We need to reduce the remaining two elements in that column, that is 2 and 3, to 0, and that 2 also we have seen in the inverse of a matrix, how to get the inverse of a matrix. So in that case also we do the same steps. So here we need to reduce 2 and 3 to 0 with the help of the diagonal element 1. So for that, since this one is 2, I have to make this 1 to 2 by multiplying it by 2, means multiplying that entire row by 2 and subtract. So that transformation will be like this, R2 minus 2R1. So 2 minus 2 becomes 0. So this element will become 0. Similarly, to reduce the third element of that column, that is 3, to 0, as since this one is 3, I have to make this 3 by multiplying this entire row by 3, means 3R1, and subtract from this R3 because 3 is in third row. So the transformation will be like this, R3 minus 3R1. Hope everyone got this. So now let's apply this to the matrix equation Ax equal to B. Okay, so what we have, R2 minus 2R1 first. So whenever we are transforming R2 using the transformation R2 minus 2R1, the change will take place only in R2, not in other row. So first row should be written as it is. Here the first row is 1 to 1. I kept 1 to 1 as it is. Okay, and now apply this transformation on R2. R2 minus 2R1. So if I multiply all elements in R1 by 2, they will become 2, 4 and 2. Okay, and then subtract from the elements 2, 3 and minus 1 respectively. So here we have 2 minus 2 will become 0. Then 3 minus this becomes 4 now. So it is 3 minus 4. So 3 minus 4 will become minus 1. And then minus 1 minus 2. That gives us minus 3. The same transformation should be applied to this right side matrix. That is the column matrix 8, 11, 5. So R2 minus 2R1. So here this 2R1 makes this 8 as 2 times 8, that is 16. So 11 minus 16. How much is 11 minus 16? It will be minus 5. Is it clear? Now after transforming the row 2, now we transform R3, that is the third row. So in the third row, here we have 3, the transformation is R3 minus 3R1. So multiply each element of R1 by 3. Okay, so they will be 3, then 3 2s are 6, 3 1s are 3. So it will become 3, 6, 3. And then subtract the elements from the elements in row 3, that is R3. Okay, so it gives us 3 minus 3, 0, minus 1, minus 6, right? Minus 1 minus 6 will become minus 7, and then minus 2 minus 3. So minus 2 minus 3 makes this minus 12 minus 5. So we have the third row as 0, minus 7, minus 5. And then the same should be applied to the right side matrix also. Here if I multiply this 8 by 3, this becomes 24. And take the difference, 5 minus 24. How much is 5 minus 24? It will be minus 19. Is it clear for all? Okay, fine. So now let's see next transformation. Now we need to reduce this element. The only one element is left now to get a matrix in upper triangular matrix. So this minus 7 is left. I have to make this minus 7 to 0. So before that, make this diagonal element to 1 if it is possible. Here it is minus 1. If it is possible, you can do it. Otherwise, if you keep it as it is and you are getting this minus 7 with to 0, reducing this minus 7 to 0 with the help of minus 1, it is also okay. Answer you will get correctly. Okay, so here it is possible to make minus 1 to plus 1 just by changing the sign of R2. So I have done the same transformation, use the same transformation as minus of R2. So that minus of R2 will changes the sign of all elements in R2 of the left side as well as right side matrix. So that I have the row, second row as 0, 1, 3 and 5 to the right side matrix. Okay, so after getting this, now it is easy to reduce this minus 7 to 0 with the help of plus 1. So what I need to do, since this one is minus 7, I have to make this diagonal element 7 by multiplying this entire R2 by 7. Okay, so multiplying that by 7, what this gives us, your second row will become this 7 into 0, 0, 7 into 1 7, 7 3 are 21, and this 7 5 are 35. So it gives us 0, 7, 21 and 35, and then subtract this from R3. Or here we need to just add, not subtract, because already these two elements are in opposite sign. So if they have equal sign, then only we need to subtract, but as they have opposite sign, we need to add them. So just adding them, what will happen? Let us see here. R3, the transformation is R3 plus 7 R2. So apply this to these two matrices, left side as well as right side matrix, that is A and B. So what this gives us, your R1, R2 remain as they are. As I told you, whenever the transformation is applied to that particular row, only that row will change. Remaining others will remain, rows will remain same. Okay, so here R3 will change. I keep R1 and R2 in both of these two matrices same. If you see here, 1 2 1 remain as it is, 1 0 1 3 second row remain as it is. To the right side also 8 and 5 remain as they are. So now apply this R3 plus 7 R2. So what this gives us, 0, here it is, minus 7 plus 7 will make this 0, minus 5, and it is multiplied by 7 here, this will become 21. So minus 5 plus 21, how much it will be? It will be 16, right? It is equal to the right side also, we have to apply the same. So what this gives us, minus 19 plus 35, because I have to multiply this 5 to 7. So 5 7 are 35. So minus 9 plus 35, how much it will be? 35 minus 19, this will become 16. Is it clear for all? Okay, then what we do? What is the next step after reducing the matrix to upper triangular matrix? Here I have, this is the upper triangular matrix. Elements below the diagonal are all equal to 0. So I have these elements, non-zero elements are here. Okay, so what is the next step after getting this in upper triangular matrix? We have to take the product of these two matrices to the left side. So what that gives us? So again applying the method of taking the product of two matrices, as this one is a matrix of order 3 by 3, this is a matrix of order 3 by 1. So number of column in the first matrix is equal to number of rows in the second matrix, 3 3. So I have the product matrix in the order of 3 by 1. It will be of this type, as I discuss and explain how to get the product of matrices. We have to check the number of rows in the first matrix. Here we have 3 rows, R1, R2, R3, and the columns in the second matrix, to which we need to multiply. Here this matrix has only one column, so each row will have only one element. So number of elements will depend on the number of column in the second matrix. So since it has only one column, elements in each row will be only one, and they will be here R1 with C1. We have to multiply R1 with C1, then R2 with C2, and then R2 with C1, and then R3 with C1 only. The column remains same, just we need to change rows, R1, R2, R3, because we have 3 rows in the first matrix. Is it clear? Then we have, what are R1 C1, R2 C1, R3 C1? They will be like this. So we have to multiply each element, the corresponding element of the row 1 to the corresponding element of row, that is column 1. That is, first element should be multiplied to first element, that is x. 1 into x will be x, plus second element will be multiplied to the second element, that is y. 2 is multiplied by y, that gives us plus 2y, plus this 1 is multiplied to z, that gives us z. So that is plus z. So I have the first element of the this matrix, product matrix, as x plus 2y plus z. Similarly, now come to the next, R2 C1. What is R2 C1? Here we have R2 as 0 1 3, that will be multiplied to the column matrix x y z. Now since the first element is 0 here in this row, the first element is 0, this 0 is multiplied to x, so that gives us 0x. So one variable will be vanished here. Okay, so 0 into x will become 0, so x will be vanished, and you left with only two variables, y and z. So let's see here what we have. We have, if we multiply this row 2 to C1, we have 0 into x 0, 1 into y y, 3 into z z. So it will be 0x plus y plus 3z. So here I have 0x plus y plus 3z. This is your R2 C1. Then R3 C1. So R3 C1 will be, this is your R3, this is your C1. Now if you observe in R3, you have two elements 0 and only one non-zero element is there. So what will help you to find the values of these variables? So if you multiply this R3 with C1, if you see, this first element will be multiplied to 4, that is 0 will be multiplied to x, second 0 will be multiplied to y, means 0 into x will become 0, 0 into y will become 0, means you are vanishing the two variables x and y, and you left with only the third variable z. Okay, so that gives us the element in the third row as only 16z, 0x plus 0y plus 16z. That 0 multiplied to any term will become 0. So only one non-zero variable, the variable left in this row will be only one, that is z. So after getting this matrix, now I need to equate these two matrices. So by equality of two matrices, what we have, when the two matrices are equal, the two matrices are equal only when their rows are equal, that is the orders of these two matrices must be equal. Okay, so once the orders of these two matrices are equal, we have to equate the corresponding elements. Since already the matrices are equal, we have to equate the corresponding elements. So what this gives us, corresponding elements. So if I equate, this first element should be equated with first, second with second, and third with third, because they are matrices of same order, that is column matrices of order 3 by 1. So corresponding elements must be equal. So what this gives us, by equality of matrices, I have from the third element will be equated with third. It has only one variable, so 16z will be equated to 16, so which gives us the value of z as 16 upon 16, that is equal to 1. So I got the value of z as 1. Now come to the second equation we have from second element of this matrix. So I can equate this y plus 3z with 5, so that gives us y plus 3z equal to 5. So now I can use the value of z we got here in the first step. So y plus 3 times z, so z is 1 here, equal to 5. So y plus 3 equal to 5, or y equal to 5 minus 3. So that gives us the value of y as 2. Okay, and then now from the third equation, that is from the first element of these two matrices, we can have x plus 2y plus z equal to 8. Okay, so this equation is having three variables x, y and z, and we already found the values of two variables y and z. So we need to just substitute these two values of x, y and z in this equation and get the value of x. So what this gives us, we have x plus 2 times 2 plus 1 equal to 8, that is x plus 2 2s are 4, 1 equal to 8, that is 4 plus 1 will be 5. So that 5 will be taken to the right side and subtracted from 8. So x will be equal to 8 minus 5, which is equal to 3. So in this way I can have the values of x, y, z, that is the solution of given set of simultaneous equation of 3 equations, 3 variables. So in this way you can find the solution of simultaneous equation by using the matrices. So it is one of the important method of finding the solutions of simultaneous equations by using the matrix, and this is the method number 2 known as reduction method. Hope everyone got this method clear. Even then, just we need to go again and again, try more examples, try to solve more examples from the exercises, and even then if you have any question, you can just message me. The contact details are already given, so you can just go through it and you can message me, or you can just give your feedback to improve the quality of the content of my video. So till then, in the next video I will definitely with one more important concept from the mathematics. Okay, so till then keep learning. Thank you very much.